Thank you. Good morning, I guess still for another 18 minutes, everybody. So today I'm Spartak. I'm going to be speaking about managing your server-side Swift at scale. And I'm going to present to you different ways of managing your infrastructure from deployments to scaling, to auto-scaling, using all the pretty much giant open source tools that exist out there. Before I dive into it, a little bit about myself. So I've been in the technology development field for over 20 years at this point, honestly, when the only option for server-side was Perl, or you would have to write some kind of a CGI using C, C++. I come from a large-scale enterprise background, so I know what it is to launch production-ready applications and the value of that, and really one area that I think Swift really needs to overcome that hurdle in order to be ready for larger enterprises to be able to adopt that. I also teach back in LA. I teach at the USC School of Engineering, so I teach their advanced iOS development course. So I literally produce about 30 new iOS engineers a year. So it's kind of cool. You know, you take my class if you want to be an iOS engineer, so little do they know. Before I dive into it, can anybody tell me where this picture or what this quote is from? Dig deep into your childhood stories. Yep. Who you got it? Awesome, yeah. So this is from Robinson Crusoe. If not many of you may recall or are not familiar with it, he basically gets stranded on an island. He finally spends, after a lot of time, building this nice boat. And after it's done, it's too far away from the beach. He can't get it into the water. So he spends a lot of time into it. And you know, it's bigger than any canoe he built, which he failed to get out. But he just has a hard time getting out into it. We've been on the server-side Swift arena, I guess, for a little over a year and a half, 2 years at this point, and we tried to take a very data-driven approach where we really wanted to analyze what's going on in the industry, what is it going to take for it to adopt it. Our company was actually part of NSF, National Science Foundation, in the US, and so we did this extensive study where we interviewed literally CTOs and you know, VPs of engineering and whatnot, to see what is it that's going to take them to adopt something like Swift on the server side, because the value proposition is great. You know, you're ultimately offering them that their mobile app developers can now become full stack developers. So how do we get there? And the big problem, as Tanner, you know, kind of opened up the topic, the struggle is very real. You know, you're taking average mobile app developers, which are younger developers, so they don't have necessarily the years of experience to know all the server-side technologies, all the science involved between Linux, all the different layers between, you know, when launching a server-side, which operating system am I going to choose for doing that? All the DevOps tools and all the logic that's involved in science that's there between managing Docker containers to potentially Kubernetes if you really want to schedule on, you know, fleet of services, running behind, you know, large open source giants such as Nginx or HA Proxy or Apache. How do you configure all of that? And lastly, choosing between all the providers. It seems like the cloud providers are super easy to get locked into. You look at AWS, you look at, you know, other ones. You get a lot of, especially if you have a startup, you get something like, with AWS, we're part of a VC accelerator, we got like $200,000 worth of credit. That lasts you 1 year. And then what happens is you build your infrastructure on that cloud provider and you're locked in. You can't just pick it up and move somewhere else because you are so dependent on their systems. So today I'm going to talk to you about these various things, and it's literally launching any stack on any cloud. And everything that's being done is going to be leveraging open source, giant open source technologies. So we're literally going to ride on the shoulders of these open source technologies to show you how you can develop a cloud infrastructure that allows you to run in concert, even if you wanted to choose all the 4 different Swift on the server-side frameworks, do microservices, and literally have an easy transition out of one cloud infrastructure to another, and have a self-documenting way of what your cloud infrastructure looks like. So with no further ado, let's take a peek under the hood. So, as Tim mentioned, I am going to be coding half of this, so hopefully I'll have some time left, but I do want to kind of do a primer on the various tools and technologies that are used behind this. One of the prominent ones is Terraform. Basically, Terraform is infrastructure as a code tool. It's similar to CloudFormation that AWS has, except it works with most popular cloud providers. You declaratively define your infrastructure in code, where typically right now you may have a DevOps person, or you yourself may go set up an instance, launch an Ubuntu instance, for example, do a whole bunch of apt-gets to update it, to get it primed up to a place where it's functional. And none of this is documented. If you have to launch or scale that again, you don't remember which version of what, how did this happen, and you don't know what dependency hell you're building in there, where you update some framework and it breaks something else. So Terraform really helps you, instead of doing this manually, to do it in code. Some of the benefits are obviously you become completely cloud provider agnostic if you set it up the right way. It's obviously tempting, when you're going into AWS or whatnot, you may want to still leverage their load balancer, but when you switch out to a Google Cloud Code or IBM Bluemix, you will be able to leverage the tools that they provide. Creation and consistency. So what this allows you to do is, in any production environment, you have your production, you have your staging, you have your development environment. So how do you make sure it's consistent? How do you make sure that what you're doing, your production may be a full-fledged, 20 servers handling a load, but hey, for your development, you want to be able to, on the spot, create instances and destroy them. So essentially, this goes with the notion of immutable infrastructure. You get declarative control of the cloud resources. You can apply incremental changes. What that means is you can use source control. So you can actually go back and see, what did my infrastructure look like a month ago? What did it look like a year ago? Your infrastructure is now part of your code. It's no longer something that is tribal knowledge between the DevOps team that's doing it, but rather it's documented and everything is launched for you. You can preview your changes, you can replicate and scale easier, and most importantly, we had a discussion about this earlier, it's a form of documentation. It's the source of truth. You can actually, as long as you invest in doing this infrastructure as a code framework, everything you need to know about which servers depend on what provisioning takes place when something gets launched, it's all documented within Terraform. So some basics, as I'll jump into coding, Terraform uses a language called HCL. It's more like a YAML type of language, but Terraform is actually ran by a company called HashiCorp. So it's their own language. It's an easier version of kind of like YAML between JSON. We'll get into that. It uses state files to maintain current state of your infrastructure. What this means is you won't accidentally delete servers by using Terraform just because you gave it access. It only, as it launches servers, it maintains a log of which server IDs that it did, so it can only affect the servers that it's managing. And it's got some safety mechanism where you can declare things. Obviously, with great power comes great responsibility. You don't want to just take down your infrastructure. So it does have some safety mechanisms in doing that. As I mentioned, you can preview your changes and, again, easily control replication and scaling. So the next tool that, as a result of yesterday's workshop, hopefully all of you are familiar with, it's Docker. It's basically a containerization system. Benefits of using Docker is isolation, security, compatibility, maintainability. You can do continuous deployments, and it launches the same way everywhere it goes. You can launch it on your Mac OS, on your laptop. You can launch it on the server. It's got, it's simpler, fast configuration, and again, you can replicate and scale easily. Some of the basics as we dive into it for Docker, you got your images. These are essentially your classes. You got your containers, which are instances of your classes, if I was to draw a parallel into the object-oriented programming. You got Docker Compose that lets you do really cool stuff. You can literally, within a Docker Compose, define an Nginx, define, Vapor or some other server-side.swift, say how they're going to connect to each other, and they'll connect to each other in their own kind of little network, and then be exposed to the world, running through their own, through the Docker interfaces. You got the Docker engine that lets you control what's happening with the Dockers as far as starting, building, running, and the registry. So once you compile the Docker, initially it takes some time to kind of pack it up into one, but then you check in your Docker into a registry, so it's super fast to check it out and run it on any instances. So we'll also take advantage of that to deploy infrastructure. Last but not least is CoreOS. How many of you, by raise of hands, have heard of CoreOS or know somewhat what it does? Awesome. Good portion. So for those that don't, CoreOS is basically a fresh approach to a Linux operating system. It's based on Chrome OS, actually. It's built on top of that. And basically, if you currently launch any server-side instances, and you're choosing, let's say, between Ubuntu, or you go stripped-down version of Alpine, or if you require, you may in the future Swift start supporting Debian or CentOS or something like that. What you end up struggling with is every few weeks you're constantly doing the security updates and patches and maintenance and all this stuff for things that are completely unrelated to anything that your Linux operating system needs to be doing. So the approach that CoreOS does is it says it's a container operating system only. It's Linux-based, and it can only run and manage containers. It's got a lot of security. It's very heavy security-based, so it doesn't have unnecessary services running that you're not aware of. What did Ubuntu boot up that I'm not aware of? Especially as an iOS developer, there's dozens of services that may be running with any default Ubuntu installation or any other Linux installation. So it's based on security. It's basically just clean, lean, container only. It can do hot updates of the operating system. So you don't have to reboot this. It can actually update the operating system and switch what it's running on in a live instance. It supports cluster infrastructure natively. So what that means is you can run a cluster of these, and I'll get into some of the tools it uses where you can have your own virtual private network spread over a cluster of different services where all your applications, all your containers can actually be talking to each other through local IP addresses. And this can span across different cloud providers. It naturally integrates with Kubernetes. So actually, any Kubernetes talk I'm seeing now is being built on top of CoreOS. And you're up and running very quickly rather than wasting time with downloading all the different software and whatnot to get it running. Basically, the whole philosophy is CoreOS will be up and running. There is a nice ignition file that you just, for its provisioning. The rest, you do it in your Docker container, which you can develop and test on your local machine and just deploy to the cloud. So a little bit of the CoreOS basics. It uses Ignition user config files. So you basically, again, declaratively kind of set up your systemd units where you say what services you're going to run. And these services, when they start off, we'll get into examples of those. You can give it what it needs to do before the service is ran. So if you want to download some source code or do some updates, whatnot, and then you basically typically just say, run this Docker instance, and you can provide it environment variables and whatnot. It natively comes with etcd. etcd is a key value store. It's a distributed key value store. So if you put your CoreOSs on a cluster, you can actually listen. One CoreOS, let's say you're auto-scaling. You have some kind of a logic that's monitoring how much traffic your site is getting. you can write the, you can trigger for other instances to scale themselves, to launch more Docker containers and whatnot. And Flannel is also an important thing to know when it comes to CoreOS. This creates a virtual private network inside the CoreOS. So you're able to, even across different providers, across different virtual private clouds, have essentially a seamless private network for your containers to communicate with. So enough talking, and I'm just going to dive into the demo now. Just bear with me a second. I need to mirror my screen, so I'm not looking over there. I'm sorry? Oh, okay. Oh, that scale really. I'm a Mac developer. I'm just used to the GUI stuff, not Command F1s. Increase my resolution so it's easier to read. Awesome. So I'm going to dive into the code. So a couple of things to note. Is everybody able to read that, or do I need to go a little larger on that? I think I need to go larger, right? Yeah. Oh, that's not larger. Is that better? One more? Let's go one more. Yeah. Nice. All right. So one thing, we're talking a lot about documentation and how do you overall maintain control of everything that gets done. So everything that our team does, we use a makefile. Because what we want to do is we want to have an easy handoff. So when one of our developers is working something in one time zone and he has to hand it off to the other one, we don't want the other guy to guess what kind of shell commands was he running, even if it's, he's using the Swift package manager and just compiling it through that or something. So everything that any of our developers do is in the makefile. I'm going to actually share this on GitHub, the entire project, so you guys can have it. So you'll see me issue a lot of make commands. Essentially what we're doing with the make commands is it's a documentation, so we don't have to retype it, like all the way to how to SSH into our servers, to generate SSH key, to transpile some configurations, whatnot. If it's a shell command that a developer uses, it has to go in the makefile. Because I myself may be very fluent in using some shell command. I come back a year later, and I'll hate myself for not leaving some kind of a trail of documentation of what I was doing. So the best documentation you can do is actually documentation you actively use. So you'll see me issuing a lot of make commands. Now, this is Terraform. I'm inside Terraform. Terraform, as I said, is declarative definitions of what your infrastructure looks like. So it's got some keywords. Basically, the way Terraform works is when you issue the command called Terraform apply or Terraform plan, it scans that directory for every .tf file, essentially kind of like merges them together, and it extrapolates all the dependencies and then tells you the plan of how it's going to deploy. So here what we've done is I have a provider defined. This is for running in US West 2. I have the access key that I'm not going to show here. That's to our cloud provider. But this is what template looks like of variable access keys. You typically want to maintain this independently. You don't want to check it in. You only want to hand it off to developers that actually need to check something into the cloud. And this is kind of a simplistic, just getting started with Terraform type of a view. It has a lot of nifty features. So you can define your resources In this case, we're defining that we're going to have one AWS instance. We're going to call this a demo instance. We're going to take an image. This is provided by CoreOS, an AMI with this ID. So we're going to create that instance. You can define the type. In this case, we're defining that we want to launch a T2 micro instance on AWS. I'll get into, this is just basic CoreOS because it's secure. It requires you to have kind of like a private subnet set up, especially with their configuration. So there's a lot of networking layer that's going on, but I just want to demonstrate the power of this, that even my VPC that's set up in AWS is all fully documented within Terraform. So for example, I start off with, I have an AWS VPC called demo VPC. I have an internet gateway for that VPC to provide all the external traffic into it. There's a subnet that defines a local level IP addresses. There is a routing table. So all these things that are required for CoreOS that you guys can just copy and paste once I share this demo. Lastly, I have a security group set up. So I can know what is my instance being exposed to. So far, I'm just letting it be exposed to SSH port because I want it to. Eventually, what I'll do is I'll block it off so maybe only my VPN server can access this via SSH or completely shut it off. I also have port 80 open, the TCP. Ingress port 443 for SSL. And for egress, I have all the ports open so the application from inside out can communicate. But you can see how it's already, wow, I know exactly what my infrastructure looks like. I don't have to go guess that the person set it up somehow through the GUI in AWS or in any other cloud provider. What kind of configuration did they do? So back to this. So that's using the VPC ID. So this basically associates this instance with that virtual private cloud. Then I have like key names and the subnet ID. So these are all just basically associating it with that virtual private cloud. Lastly, as I alluded to, because we're launching CoreOS, it supports what's called user data. It's called an ignition file. And this user data is essentially defining in a YAML format what services are going to be running in that CoreOS. I never actually touch CoreOS. All I do is I define it, and I'm going to hit just, type in one command, and if our network connection is good, you'll see it launched. So, but what I'm doing here is I'm declaring all the different units and services that can start. So it's kind of amazing because you can define dependencies. So for example, here, this is a system D unit that I'm defining. This is going to run a Swift engine instance. It's going to depend on, it's only going to launch and run after the Docker service starts, because I want to make sure the Docker engine is running. And it's going to require a Docker service. Before it runs it, there is some execution that needs to take place before it runs it. What I'm going to do is I'm going to download the latest version of the source code from the master repository of the code that I want to run. I'm going to unzip it into a specific folder, make sure that there is a read access to that folder. And lastly, as part of the process that this systemd unit is going to start and monitor, is going to be the Docker instance, where I'm going to map the volume to a local volume where I unzip the folder, and mapping my ports to whatever port that I know my Docker is expecting to be listened to, mapping it to the port that I want the public to have access to. So I won't get too much into details into that because there's a lot we got to cover. So next thing is the life cycle. The life cycle, I've defined it to create before destroy. Why do I want to do create before destroy? Because now we're in the land of immutable infrastructure. What does that mean to me? My instances are nothing. I can create and destroy an entire fleet of instances. So how do I want to do hot deployment? Obviously, when you're doing a hot deployment, I'm going to be taking down one entire instance, launching a new instance, or if I want, I can take down a container, launch another container. The power is in your fingertips at this point. But what I want to do is I want to make sure that anytime this instance is going to be updated, I want to make sure you create the new instance before you remove the old instance. And Terraform will handle this for me. And lastly, there is just a simple script I have written here that's called it executes locally after it's done, once the service is running, because there is some boot up overhead for the instance to get up, for it to download the Docker image, for the server to come up and running. So all that is it's running this local command. It's called local execute, where it's just constantly looping, waiting for sleep, just pinging the new system, the new IP address, to wait for the server to come up. So once locally I detect that the new server is up, then Terraform considers that the instance is up, because that's when I release that command. So this way, I will, if I'm doing a hot deployment, I will wait for the new system to get provisioned, to get boot up, for the server to be running. Once I've confirmed through some health check that it's running, then I let Terraform do its job of destroying the old system and mapping the elastic IP to the new system. So a couple of other pieces of information. I have a key pair set up here. This is my SSH key pair. So I typically keep it in this .ssh folder where I have my RSA key and the RSA pub. So this is defined, so it's, you can only access this instance via SSH key. You typically don't want to do a password. So the ultimate way you can probably secure your SSH is only let one IP address access it, which is your super secured VPN, and also have a SSH key. Lastly, I wanted to keep this example simple, so we're going to be just using an elastic IP address, because as I launch new instances, AWS is going to provision and give me new public IP addresses every time I launch a new instance. I don't want to do that, so I have a resource defined just for my elastic IP address. So notice I haven't gone into AWS at all, but I just gave you an overview of my entire infrastructure. So if you're a new developer, you just have to spend a little time, read through this, and everything is kind of shown together, all the dependencies and whatnot. Lastly, just Terraform has this cool output where I can define, once it's done, what happens is it's going to print some stuff out for me. I just want to know what the IP address was where it deployed. So let me just jump into first. This is the modern day magic part, so there's nothing there. This is my infrastructure. It's in Oregon. So what I'm going to do is I'm going to come here, and I'm going to first ask Terraform, show me the plan of what you're going to do. So I type in make plan, that executes a command called Terraform plan, and it printed out for me. See, I'm using the shortcut now. So Terraform told me all the things it's going to do. It's going to add an elastic IP. And these are going to be the values that it sets, and this elastic IP is going to be associated with a VPC. It's also going to add an instance called demo instance. It's going to be this AMI, and everything else is going to be computed as it goes. It's going to be a T2 micro instance type. There's like a key name that I've associated with it, the security groups, whatnot. It's going to add all the networking stuff, the internet gateway, my pair key where it's uploading the public, my public key for my SSH. It's showing me all the routing tables that are associated in my virtual private cloud. It's showing me that it's going to create a security group, and it's showing me which ports it's going to allow in, which ports it's going to allow out. Lastly, the VPC. So it plans to add 9. It's not going to change any because I don't have anything there. And it's not going to destroy anything because I don't have anything. So with this in mind, I'm ready to just do make, apply. So make, apply again, told me the same thing, except this time it's saying, do you want to confirm? Obviously, there is a way to override it, so it does it automatically in case this is something you want to do more from like a CI/CD type environment. But here, I'm not going to get into it again, but apply told me the same thing. It says, do you want to continue? So I'm going to hit yes. And as I hit yes, in the background, it's now connected to AWS. So I'm going to keep on refreshing this until for now, it just set up my virtual private cloud. It set up my security group. It created the routing table. It knows the dependency, so it knows instance depends on all of this, so it knows the order of which it's going to do. I've actually had the opportunity to meet with the founder of Terraform, the HashiCorp. His name is Mitchell Hashimoto, so really smart guy. His whole vision is how do you make it simpler. So it's already set up the virtual private cloud, so what I'm going to do is I'm going to come and refresh this page. So my instance is running, but the services are not up yet because now it's executing that local script. It grabbed the IP address, so now it's constantly pinging it every 5 seconds to check if the service is up. So what's happening right now on the server side is it's downloading the Docker image, it's running the Docker image, it's putting up the Swift engine server. See, and I require no bandwidth at all. All this is less than 1 JPEG image. All right, so it just created the instance. It's now creating my Elastic IP. It told me that it added 9 instances. It gave me my Elastic IP address. So if I go to that server now, I should be able to see a response. Well, let's load it up there. And we have hello from Swift engine. So now I'm going, thank you. I'll stop here. So now I'm going to do an update. I'm going to do a hot swap of my infrastructure. So to do that, I'm going to first test my code. So I did, today's focus was really on the deployments and whatnot, but Swift engine is a different approach. It's an alternative approach to the existing frameworks. Some of the things that we try to do is basically lower the barrier to development for Swift developers. So what does that mean? To us, we want to make sure it's super easy as far as compiling. So it automatically compiles. It's literally like PHP, except Swift, where you just save your file and it compiles. So if I, for example, save this file, it's saved locally, and then I can just reload it. It's running on my local host. Watch this, how it's going to change from 7779 to something else. It compiled locally. So we're essentially we're kind of like bridging between what Package Manager does and loading the compiler ourselves, where we generate from source file the actual object files, where we then link them together. There is core libraries that we're using shared object files on. One of the other things, again, when we walk into an enterprise and they're asking us how long you've been around, no matter how great our team is, your driver that's been tested, time-tested, your Postgres driver that's been time-tested for over 20 years, written in C or even in Go language, is still going to be less of a burden for them to do. So that's some of the things we're doing. Another thing is there is a safety mode. So how do we accomplish safety mode? No, we don't spin off a process per request, but we do have a pool of processes that are running, and we have a safety mode where it will channel only one process per request if you're just developing a new application. And honestly, for the most part, you can easily run 50, 100, 150 processes on a pretty small instance. And if you're just launching a site to be able to handle 50 concurrent at that moment processes, means you're handling thousands of connections. And then once you're done with safety mode, we do have a ludicrous mode where you can essentially, it's more of a, we basically, you can still have a pool of processes either distributed on different CoreOS systems where we're channeling it, but then they can handle themselves asynchronously. So this is actually something that we're working on. We are now on top of Swift Neo as of very recently, so we've embraced into that world. So it's helped a lot. You have no idea. So, one other cool thing I just want to show here real quick. If I, let's say, declare something like that, the benefit of, and then let's say, let my bar 2 equals, let's make this a string. So I'm just writing some random stuff to make the code crash. And what I want to show you is this feature. You get the full debugging and linting in the browser. So we're actually taking the output, we're disembolicating the file and showing you in which file, which variable, which line of code you came in. So it's something we're just kind of taking the abstract. We want to, look, PHP is, no matter how much you argue about it, it's still the most dominant force on the web. And it's just because it's made it so simple. So we're trying to find a way, how can we make Swift simpler for people to use without the compromise? Everybody, you don't know what framework force unwrapped something underneath the hood that now you're stuck with debugging or trying to deal with that. So that's part of the thing. Anyway, a little detour. So now I have this updated. I'm going to say hello from ServerSide.swift in Germany. And I'm going to change it to V, let's say 55. Saving that. Let's make sure this runs. So that compiled. It only compiles the first time, so second time it's already hitting a compiled object. I'm going to check this into my source code real fast. And as that's checking in, what I'm going to come do is I want to show you the hot deployment now. So what happens when I do the hot deployment? Where is my makefile? I have a rule here called deploy. And what it's going to do is call taint. I'm basically going to tell Terraform, taint that instance that I have up running. So that way, when I run Terraform apply, it's going to say that's a tainted instance. So I need to run a new version, launch a new version of that instance. Because Terraform doesn't know that my code in the cloud got updated. So I'm going to run make deploy. So first thing it did is it tainted that instance. Now it's calculating what is it going to do to my infrastructure. Again, I could have had like 300 other instances there. Terraform has no idea. You can, in fact, run independent Terraform instances on the same token. It only knows that it keeps track of the state that it itself has created. So now let's see what it's telling me it's going to do. It's telling me it's going to modify my elastic IP. It's going to point from the existing instance to the new instance that it launches. It's also telling me that it needs to launch a new resource. So it's going to force a new resource to launch. And obviously, I have create before destroy. So it's only going to create the new instance before it launches the new instance. I'm going to give it a yes. So now let's see some magical stuff happening here. So you see it's already creating my second instance. exact same replica, except it's going to grab the latest version of the code I just pushed to the cloud. So that's going to take a moment, and then once it's done, so that's running. So that means now it's just waiting for the new server to boot up. Any questions while this is taking place? Because it usually takes about a minute.
Yeah, microphone on. Yep.
So you mentioned the log file that is kept to kind of like keep track of the actual state on AWS.
Yeah.
And would you have to share this between all developers that use Terraform? And if so, how do you share it?
Great question. So the log file and the passwords file, you typically don't want to check it into the source repository. What you can do is set up like a S3 bucket, or HashiCorp itself, they have an Atlas cloud, because you can actually specify in your Terraform which remote site to get the log files from. So if you just did an update and I didn't happen to check out the latest commit, I will immediately know that you've locked it, so I'm not doing an update at the same time. Great question.
More questions, or do you want to?
Yeah, sure. While it's running. So real quick, so now my new instance is online. It repointed, so it completed in 1 minute 43 seconds, and it pointed the elastic IP address to the new one. So now what it's doing is it's destroying the previous instance. So we don't really care about that, but I'll show you what it looks like anyway. So it should say terminating or shutting down the previous instance as it's running the new instance. And but our new site should already be up. So if I refresh this page, we should get from server-side German.